So section 4.4 going to be rules of exponents. Okay. All right. So as we start going through this, I'm going to go through and I'm going to give you the rule. All right. It's a generic rule. And then we're going to go through and do some actual examples. All right. So the product rule. This is when you're multiplying and the bases are the same. All right. So you notice that they both have an x. When that happens, all you're going to do is you're going to keep the base the same and you're going to add the exponents. Okay. So when the bases are the same, add, and you're multiplying, add the exponents. All right. So let's look at the actual example. So in this case, we have a base of h for both of them. All right. So remember, when you're multiplying, and we're multiplying there. So we're multiplying, bases are the same. We add the exponents. So then this one is going to be h to the eighth power. All right. Now with b, this one gets a little bit messier, but it's still not too bad. When you look at this one, the thing I want you to notice is the coefficients, -2 times 7. Multiply those together. All right. You'll notice they both have a base of a. All right. So you're going to have a, and remember we just talked about the product rule. Add the exponents. Okay. And then they both have a base of b. But you'll notice there's no exponent in there. And you just got to remember, people in math are lazy as hell. They don't have to write it, they're not going to. So you have to make sure that you know that both of those bases of b have an exponent of 1. So 1 plus 1. Sorry, that's supposed to be a 1. All right. So now -2 times 7 gives me -14. A to the fifth power, b squared. All right. The power rule. This is when you have a power raised to a power. So you'll notice you have a power raised to another power. And in that case, when you have a power raised to a power, you're just going to multiply those two exponents together. Okay. And now we can also just write it as a, b next to each other. Okay. So when you're multiplying variables, you can just write them next to each other. All right. And now the other part here is, let's say you have two numbers that you're multiplying together. So x times y, and they're both being raised to one variable. You can split it up if you have to. So x to the a times y to the a power, right? Or like we just said, when you have variables, you write them next to each other. Whoops, sorry, that's supposed to be an a. Okay. All right, so now let's look at the actual example. Here, x squared have one power raised to another power. So when you have that, it's going to be x to the 2 times 7, which is going to give me x to the 14th power. Now for part B, it's still power to a power, but if you look at it, 5 has an exponent of 1. So with this problem, you can write this as 5 to the 1 times 5 power times y to the 2 times 5. All right, so power to a power. So again, that 5 had a power of 1 inside the parenthesis. So 1 times 5 gives me 5 to the 5th, and then y to the 10th. And then you grab your calculator, and 5 to the 5th ends up equaling 3,125 y to the 10th. All right, that's just calculator work though. All right, quotient rule. Well, if you look back up here at the product rule, this is the one where it said if you're multiplying and the bases are the same, you add the exponent. So the quotient rule is if you're dividing, all right, if you're dividing and the bases are the same, you're going to subtract the exponents. All right. So in this case, you're going to have x to the a minus b. All right. And then with x over y. All right. So you still have a fraction there, but this one is very much like this one up here, where you're just kind of distribute the variable to both of them. So you're going to have x to the a over y to the a. Right. In my opinion, this is still a power raised to a power because x and y both have an exponent of 1. Right. So now let's look at some actual examples here. We have 5 to the 7th over 5 to the 3rd. Bases are exactly the same. Okay. So we're going to subtract those exponents. We're going to subtract the exponents. But I like to think about it like this, because 7 is bigger than 3. All right. 7 is bigger than 3. Let me erase that crap. Since 7 is bigger and it's up on top, I'm going to do the work. All right. I'm going to do the work up on top. So it's going to be over 1. All right. Again, 7's bigger than 3. So I'm going to do the work in the numerator position. So this is going to be 5 to the 4th power over 1, or just simply 5 to the 4th, which ends up being 625. Okay. Part B, x to the 9th, y to the 9th. All right. This is a simple one. Just think about it again as a power raised to a power. Nothing tricky about that one. All right. Negative exponent rule. So anytime we have a negative exponent, I immediately want to think about it as a fraction, because the only time we can have negative exponents is in scientific notation. Here, I want this to be a positive exponent. Since this is, oh crap, sorry. I was trying to use the highlighter. Since that's a negative exponent in the numerator, I'm now going to have that be a positive in the denominator. So it's actually going to be 1 over x to the a. And the same thing down here, all right? Same thing down here with this one. You'll notice that the negative is in the denominator, all right? So in order to become a positive exponent, it has to be moved up to the top, and then it'll just be over 1, or just x to the a power, okay? So a quick little note here. Move negative exponents so they become positive. All right. You have to move them. If it's on the top, move it to the bottom. If it's on the bottom, move it to the top. All right. Hopefully that's straightforward enough. All right. 2 to the negative 4. Again, instantly I want to think about this as a fraction. Well, the negative exponent, so that 2 to the 4th has to come to the bottom and becomes negative. I mean, excuse me, it went from negative, becomes positive. Now I need that 1 in the numerator, and then 1 over 2 to the 4th gives me 1 over 16. All right. 2 to the negative 2 to the negative 4th power. This one's actually a little bit tricky, because really the way you should be thinking about this is, because it's not in parentheses, you should actually be thinking about it as negative 1 times 2 to the negative 4 power. All right. So if we think about this, let me erase this mess. If we think about this as a fraction, all right, that negative should actually be written right in the middle. So I still have a 1 in the numerator, and then I have 2 to the 4th. All right. And then what do I end up with? There's that negative again. All right. I don't know if highlighting helps. I don't know. You guys got to let me know these things. All right. So there's that negative. I end up with 1 over 16, but it's a negative 1 over 16. Now, if you look at C, do you notice C, the negative is inside the parenthesis? All right. So again, I'm going to think about this over 1, but because negative's inside the parenthesis, I'm going to end up with negative 2 to the positive 4th power. Just the 4 becomes positive. All right, don't screw that up. So now I end up with 1 over, well, what is negative 2 to the 4th power? There's 4 negatives there, right? Because remember, it's negative 2 times negative 2 times negative 2 times negative 2. There's 4 negatives. So an even amount of negatives becomes positive. So it becomes 1 over 16. Okay? All right, so 1 over 2 to the negative fourth power. Again, right away I'm thinking about this as a fraction. 2 to the negative 4, it's on the bottom. For it to become positive, it has to go to the top. All right? It has to go to the top, and over 1. Well, in reality, we don't need that 1 on the bottom. So 2 to the fourth is just a 16. All right, last one. Zero exponent rule. Easiest for the last. Okay? Easiest for the last. Anything to the 0 power is 1. Anything to the 0 power is 1 except 0. All right? 0 to the 0 power is undefined. Anything to the 0 power is 1 except 0. So if you see something like this, you're just going to write UND for undefined. But anything to the 0 power, right? I know I'm sounding stupid here. Anything to the 0 power is 1 except for 0. So we look at A, negative 13 to the 0 power. That negative is inside the parentheses. Anything to the 0 power is 1. But now with B, just like this problem up here, where the hell was it? Where was that problem? All right. Remember like this one. Here, let me use the green. All right. Remember like that one. When I said think about it as a negative 1 times 2. All right. Same thing. I want to think about that negative right there. I'm thinking about that negative as negative 1 times 13 to the 0 power. Well, what do I have? I have negative 1. I know I'm overcomplicating this problem, but I just want to make sure you guys understand. So I can hear you guys already. All right. So shut it. So negative 1 times 13 to the 0 power times 1. This finally gives me an answer of negative 1. Don't screw it up. All right. Now, look at this problem here, part C. Anything to the 0 power, is 1. Please don't overcomplicate this problem. All right. Anything to the 0 power is 1. Just make sure that the stuff inside the parenthesis is not a 0. Okay. That's all you have to make sure. But hopefully this is easy enough. You guys go through, do these problems. If you have questions, please email one of us. All right.